Hello, this is Jack Jackson. In this video, we're going to talk a little bit about some Chinese mathematicians and some results that the Chinese were able to uh, develop in the ancient to medieval period. So first of all, let's look at some of the different achievements that the Chinese made collectively in mathematics. I think we've talked about some of this before in the previous video, but their approach was problem solving based and they had these big collections of problems with certain techniques that they use for them. They have an established curriculum. So mathematics was one of the six arts needed to be a highly educated person, and they had these works, the 10 classics, that eventually became a basic curriculum that was used. So they sort of had a somewhat of a national curriculum for mathematics. They made the use of counting boards and later the abacus to do computations, and this kind of led to a base 10 system of numeration. They made several strides in geometry, including finding some areas, volumes, and so forth. And they used the Gogu rule, which is the Pythagorean theorem. They made some advances in trigonometry, although this probably wasn't their major area, but they did do some trigonometry and came up with tangent tables. They made good use of Pascal's triangle in working with equations and polynomials, and they did this way before Pascal did. They solved systems of linear equations using Gaussian elimination and back substitution way before Carl Gauss. They used Horner's method way before Horner. So some of these things get named after different Europeans that worked with these concepts, but they were actually known by the Chinese many centuries before they were used in Europe. They solved linear quadratic equations and with some work in higher degree polynomial equations as well. They extracted square roots and cube roots. They had a base 10 place value system with decimal fractions by the 1st century BCE. Perhaps they influenced the uh, Indians with their numeration system. They were the first to regularly use negative numbers, and at least this one gets named after the Chinese. They have the Chinese remainder theorem to solve systems of linear congruences. They had that in place at least by the 3rd century of the Common Era. Now, when it comes to pi, in the earlier works, such as the 9 chapters of the mathematical art, they use 3 as approximating pi, which of course is, correct, but it's not very accurate. But later they used much better approximations. In fact, got better than Europe of the same period. By the Middle Ages, they used decimal fractions, negative numbers, a true concept of zero with a similar symbol as we use today. So they were able to develop some significant mathematics, in many cases predating what was found in other cultures in some cases by a lot. But this was a little different in spirit than the Greek way of doing things. Their idea of proof was not the same. And so Chinese idea of a proof would be to describe how something works in enough detail that one could hopefully infer the why the basic process was going to work and that it would continue to work, but without doing what we would now accept as a formal proof, or certainly not what the Greeks would have done, as building something up as an axiomatic system. But some fascinating Chinese mathematics there. Now let me just list a few of the selected ancient and medieval Chinese mathematicians with their dates here, kind of in chronological order. This is by no means an exhaustive list. This is just lifting up a few of them. And I'm going to apologize right off the bat. I'm not good at pronouncing these Chinese names, so um, please forgive me. Also, you should know that the Chinese names, the surname, the family name is the first name. Okay, um, so here are a few of them. Luoxia Hong, from born around 130 BC, lived to be about 70 BCE, did work in astronomy and produced a calendar with a 19-year cycle. So that 19-year cycle, that basically what that meant was is you had a calendar with so many months, and a certain number of the years within that 19-year cycle, an extra month was added to basically take care of the fact that the year and the months don't exactly line up. Liu Hui, 220 to 280 in the Common Era. He was definitely more mathematical, gave more justifications and commentaries. We'll talk a little bit more about him in a minute. Yu Zi does astronomy. Sun Zi, 400 to 460. He has a distinction of being the first that we have a record of using the Chinese remainder theorem. We'll talk about that in a later video. Zhao Yang, 400 to 470, used a decimal notation, and he understood positive and negative powers of 10. Zu Chongzhi and his son Zu Zheng, you can see their dates there, 429 to 501 and 450 to 520. They were astronomers. They gave a new calendar with a cycle of 391 years. We'll talk about Zu Chongzhi in a little bit. Wang Zhotong, 580 to 640, wrote one of the 10 classics, solved cubic equations. He did some early algebra. Li Chunfeng, 602 to 670, collected and edited the 10 classics, which were named in 1084. We'll talk a little bit about him in a later slide. Zhao Zhang, 1010 to 1070. He did a lot of work with Pascal's triangle many, many years before Pascal. Li Hui did 1192 to 1279. He's the first of a group here of famous mathematicians from what we're going to call the Golden Age, the 13th century of the Common Era became a golden age for Chinese mathematics. So these next four here are from that period. He did the coefficient array method, which is used for computing with polynomials. Qin Zhushou, from 1202 to 1261, worked with the Chinese remainder theorem, the Ruffy-Horner method of solving polynomial equations up to degree 10, well before Horner. Yang Hui, 1238 to 1298, worked with multiplication, division, roots, quadratic, and simultaneous equations. Did some work with sums of series, did some areas. He did some interesting work with what we now call magic squares and magic circles. Zu Chongzhi, 1260 to 1320, a coefficient array method, polynomials and four unknowns, and sums of series. Now, that's just a few of the mathematicians of the Chinese tradition that we want to lift up here. Not unlike other areas, Chinese development of mathematics had periods of growth and others of decline. Around 200 BCE, there was at least one major book burning where a lot of earlier works are lost, and the 9 chapters, for example, was put together after that fact, probably based on some much older works, either reconstructed from earlier fragments or saved works or just from memory of the mathematicians. They also had a tradition, of course, of oral tradition of teacher passing down knowledge from teacher to student, which in some ways continues to today. But they would use a lot of their books, like the 9 chapters, for example, as a curriculum, but then there would be supplemented by oral teaching. The 13th century, as we just mentioned, was a high point, and by the 17th century, at least, the mathematics became to be westernized. There was some contact with Western mathematics before that, but by that time, it become a serious acceptance of Western mathematics. And by the time the 20th century came around, mathematics in China was pretty fully westernized and part of a global mathematics culture. I talked to a colleague of mine who grew up in China, and he said basically the mathematics that he learned was pretty thoroughly Western mathematics. But it is very interesting that the Chinese had this pretty much isolated development, which came up with a very different flavor of mathematics. It's I guess there's good and bad with that, right? I mean, it's very interesting that they came up with some things that they might not have come up with had they just been trying to work within, say, the Greek system. But it's kind of also kind of unfortunate that you have all these different pockets of folks doing really cool stuff in different places around the world, and they weren't able to communicate like we can today. So let's look a little closer at just a couple of these folks. Li Hui from 220 to 280 of the Common Era. He lived shortly after the fall of the Han Dynasty. He lived in the kingdom of Wei, which is in north-central China. When the Han Dynasty fell, there were three competing kingdoms, um, and this kingdom of Wei didn't last long, but it pretty much corresponds with his life. His mathematics was much deeper than that of the early Chinese mathematics. So when he did a commentary on the 9 chapters, and that is probably what he's most famous for. But in that, he shows a much more depth of understanding, a much more mathematical approach, and instead of just providing solutions without really any explanation, he went back and gave some justifications for those solutions. Again, not really a proof in the Greek style, but nevertheless a much more sophisticated explanation and understanding of it. Um, when he's going through here, he noticed that that they used 3 for pi in the 9 chapters. He gave that original solution, but then he approximated pi much better by inscribing polygons and using an early limit process. He also wrote the Sea Island Mathematical Manual, which was originally part of the commentary, but later separated. And it was just 9 problems. It's pretty short work, but it was showing some indirect measurements problems using what we now call the Pythagorean theorem. Zu Chongzhi. Now notice a lot of times when you're writing Chinese names in with Latin letters, there's different ways that they're written. So his name is written this way here at the top, but it's also written with this spelling here. And the reason that is there is because the way the Chinese pronounce the names and the way the Latin letters make sounds is not always a 100% match, and so there's different spellings to try to get to that idea. Um, but anyway, this is the mathematician we want to talk about. He lived from 429 to 501. He lived in Chunfeng, China, which is in present-day Nanking. The Zu family were court officials. Both his father and grandfather were prominent court officials. They also worked in astronomy and calendar work. Calendar work and astronomy was really important to the Chinese at the time. And so it was, especially when a new ruler took over, or especially a new emperor, then astronomers would come and try to reset the calendar and work with them, uh, to basically for astrological purposes, for astrology. Um, Zu wrote 10 novels, so he wasn't just doing mathematics. He served Emperor Zhao Hu, who ruled from 454 to 464, first as a city official and then as a military officer. The older calendar that we kind of mentioned earlier was a 19-year cycle with 12 months per year. Each month had 29 or 30 days. And in 7 of the 19 years, they had an extra month. So it was basically a lunar and a solar calendar. He proposed a new calendar of 391 years, 144 of which um, had an extra month added. Now, how did he know to do that this would work out much better? Well, he was able to calculate the length of the year to astonishingly accurate, to within 50 seconds for the year. And he could calculate a month within accurate to at least 5 significant digits. So he was able to take precise astronomical measurements and use those to make these very precise calculations, and then use that to come up with a calendar that tried to reconcile the lunar and solar cycles. He's also able to calculate pi approximately as 355 over 113, and he wrote a book called The Method of Interpolation, which was the most advanced of the 10 classics. It was so advanced that it was dropped from the curriculum because most of the students weren't advanced enough to learn it, and unfortunately because of that it has now been lost. The next mathematician we're going to lift up and talk about is Li Chunfeng. Again, there's a couple different spellings of it there. He lived from 602 to 670 of the Common Era. So he was born in the Sui dynasty and then did most of his life serving in the Tang dynasty. At the Shaanxi province in China is where he was from. His family were Taoist, so Chinese philosophy and religion. He was an astrologer, a prophet, and a numerologist. So a little bit of mysticism there in his makeup. He was a high-ranking court astronomer and historian during the Tang Dynasty. He wrote a history of astronomy, astrology, meteorology, and mathematics as it was developed in the Jin and Sui dynasties. He did work on calendar, making calendars for the Tang Dynasty leaders. He was director of the Imperial Astronomical Bureau, and the thing that he was most famous for, he was the editor-in-chief of the 10 mathematical classics. At this point, the idea was to come up with sort of a definitive edition of these 10 mathematical classics and correct mistakes, because there were some mistakes in the earlier versions of them. So he was able to correct the mistakes, including some of the commentaries from the earlier mathematicians we've discussed, and he compiled the works. He made 110 comments that we know about that provide historical information about and an evidence of what he actually corrected. And he eventually used better approximations of pi than were used in the original works. So we now come to the golden age of classical Chinese mathematics, which was the 13th century. And this is when classic Chinese mathematics reached its peak. There was at least a couple of centuries of lull before this with not that much mathematical development. And then after this century, there was a slow decline until Western mathematics arrived in the 16th century. But in this century, mathematics in China reached its high point, and they did a lot of very interesting things. Major mathematicians include these four: Qin Zheshou, Li Shi, or Li Yi, Yang Hui, and Zu Chongzhi. This one here in parentheses, this is not because it's a different spelling of this. He actually took a different name because He started out with this first name, and then that was the name of one of the emperors. So kept his family name the same, but he changed the other part of his name, his second name. We discussed each one of these separately and said what they did. So let's just talk earlier slides. So I'm just going to real briefly kind of talk about what they did collectively. So collectively, they worked on algebra and polynomial equations. They made good use of the coefficient array method, also known as the method of the celestial unknown. They solved simultaneous equations, did some work on sums of series. They used algebra to solve geometric problems. They found areas, algorithms for multiplication, division, root extraction, uses of Pascal's triangle, magic squares, and magic circle. Here's an example of one of the magic squares and a magic circle that they use. In a magic square, the sum of the digits in every row and every column are the same. So you can check that out there. In the magic circle, there are a bunch of different circles here. And if you take the number in the middle and the ones on the circumference of that circle, they sum to the same as well. So once again, there was a lot of really cool and innovative mathematics over the centuries from the ancient times, especially up to the 13th century for Chinese mathematics. It had a different flavor than European mathematics, but it developed independently. They may have very well have influenced the Indians in their development of the number system, so we may owe them that as well. And eventually, uh, their mathematics uh, was replaced in style with more Western mathematics, but their results then became sort of absorbed into that larger body of mathematics eventually.